Today we are going to see some important give reason type questions from amines. These questions and all will be helpful to get ideas about assertion reason type questions. Come on, let us go and analyze the first question. Why tertiary amines are less soluble in water? To answer this, we should know some ideas about physical properties of amines. Physical property, generally physical property means what is the state it belongs, whether it is soluble in water or not, or else next one boiling point or freezing point. In that way, these are the main points to be noted. Generally they'll be asking from that physical property, that only it will say. Okay, now in this amines physical property, what it is telling, aliphatic primary amines are gaseous state and it's fishy in order. Number of carbons higher level, higher number of carbons, solids in state. Okay, now amines are hydrophilic in nature, whereas hydrocarbons are hydrophobic in nature. You know the meaning of hydrophilic and hydrophobic. Hydrophilic means water liking subject, whereas hydrophobic means they don't like water. That means they will not dissolve in water. Okay, now that means what it has mentioned, amines will be soluble in water, but it will be lesser soluble. But generally what they have given idea about, water molecule, in that oxygen is there, amines nitrogen is there, so water, that means oxygen is having more electronegativity than nitrogen, so amines will be less soluble in polar like solvents. Comparatively corresponding alcohols, it will be soluble. That is what they mention. Okay, now generally here primary and secondary amines will be soluble, but tertiary will be lesser soluble, they mention. Okay, now as we are talking about primary secondary or NH2, so this is primary amine or NHR. Okay, now this is a primary amine, this is a secondary amine. So primary and secondary amine. Now tertiary amine, this is R, N, R. So this is a tertiary amine. Okay, so primary amines, hydrogen molecule is there. Secondary amines also hydrogen molecule is there, whereas tertiary amines does not have hydrogen molecule. So that means it does not form hydrogen bond with that water molecules. So definitely the solubility will be lesser part in tertiary amines comparatively primary and secondary. Okay, now boiling point, when we are talking about primary amines, are having more boiling points. Why? Because nitrogen has two hydrogen molecules, so that intermolecular hydrogen bond will be very strong. So to break that, we have to give higher temperature. So naturally, boiling point will be more comparatively secondary and tertiary. Hope you clear idea about now why tertiary amines are lesser soluble in water. Now I hope you got an idea, because there is hydrogen, number of hydrogen is nil. So naturally, it does not form that hydrogen bond with that water molecule. So it will be lesser soluble. Whereas comparatively, what it is primary and secondary, it will be soluble. Hope you clear all these ideas. And aromatic amines. Aromatic amines are colorless only, but when it is in oxidation, aerial oxidation, it will be colorful. Hope you're clear that all these points about physical properties of amines. The next question, why amines are basic in nature? To identify this answer, see, generally RNH2. So it is having unshared lone pair of electron. When it is having unshared lone pair of electron, it's ready to donate. When donating the electron pairs, we can say it is base only according to Lewis theory. Lewis base. So Lewis base, what it has mentioned? Donate electron pairs. So when it is donating electron pairs, means definitely we can say it is a Lewis base. Let us check whether it is a base or not. Generally, acids and base to combine to form, you will get salt and water. Okay, now this is that acid. So R NH2 combined with hydrogen halide. So that means what you will get is acids. So So you will get what it is, R NH3 plus X minus. So this is the salt formation only. So definitely this is acts as what it is, base. Okay, now next one more point, Lowry-Bronsted idea. So what it is Lowry-Bronsted idea? When it is accepting the proton, we can say it is a base. What it has mentioned? Lowry-Bronsted. Lowry-Bronsted. Bronsted Lowry or Lowry Bronsted, both are friends. Okay, Lowry Bronsted point, what it has mentioned, when it is accepting the proton, accepts the proton. Okay, when it is accepting the proton, we can say what it is. It is a base. Let us check whether it is accepting the proton or not. Okay, or NH2 combined with water. So what you will get it? So here H plus OH minus. So in that way, R N H3 plus and OH minus. So in that way, it accepts the proton. H plus is what it is, proton. So it is accepting the proton. So definitely this is acts as a base. So these two ideas it has mentioned. Amines are basic in nature. And of course, we are mentioning through the proof also. Hope you're clear with these points. The next question. The next question, why alkyl amine is stronger than ammonia? When we are talking ammonia and alkyl amine, both are basic in nature. Why we are telling it's a basic in nature? Because it is having what it is? Lone pair of electrons. This lone pair of electrons, what it is? It is ready to donate the electron. So that is what we are saying, it's a basic in nature. Both are having what it is, it's ready to donate the electron. When it is ready to donate the electron, it is a basic in nature. In that amount, which is stronger, alkyl amine is stronger, they are asking. Okay, now alkyl amine means this nitrogen which is having lone pair of electron, that is attached with the alkyl group. Alkyl group, what it is? Electron donating group. So electron donating group which is attached that nitrogen, that to nitrogen is having lone pair of electron. So naturally electron density will be increasing. So what happened? Due to that plus I effect, it will be taking place. So what happened? It is ready to donate the electron to the proton. Okay, or NH2, here lone pair of electrons combined with the proton, so it is ready to donate the electron to the proton, so it forms R NH3. So RNH3, it is what it is, cation formation. So higher the stability of cation, more is the basic in nature. Higher the stability of cation, what it is? This is higher the stability of cation, higher the stability of cation, more is the basic in nature. More is the basic nature. Hope you're clear with this. Why myth, what it is, alkyl amine is stronger than ammonia. Okay, why? Because it is attached to the electron donating group. So naturally it is ready to donate the electron density which is increasing. It is ready to donate the electron and plus I effect it is taking place, and moreover it forms a cation formation. So cation formation, it what it is, basic character increases. Higher the stability of cation, more is the basic in nature. Hope you're clear with it. Generally, aliphatic amines, alkyl amines or methyl amine is stronger than ammonia. Why? In that way also they may ask. Just to write the same idea, you can get it. Hope you're clear with this point. Why alkyl amine is stronger than ammonia? Ammonia does not join with anything else, just NH3. But whereas here, alkylamide, this amino group which is attached to alkyl, it is what it is, electron donating group which is attached, so electron density increases, so due to that plus I effect it is taking place. So naturally stability of cation, higher the stability of cation, more is the basic in nature. Hope you're clear. Okay, let us go for the next question. The next question. Why aliphatic secondary amines are stronger base than primary amine? The last question what we have gone through, it is a alkyl amine which is stronger than ammonia. Here primary, secondary, tertiary only there is a fight which is stronger in that way. Okay, now what they are mentioning here, secondary amines are stronger than primary amine. Okay, let us write the formula. General formula RNH2. This is a primary amine and RNHR. So this is the secondary amine. So secondary amine, here also lone pair of electrons, here also lone pair of electrons. So alkyl amine, when it is there in the secondary amine, number of alkyl group which is increasing. Alkyl group which is attached to that lone pair of electrons is having nitrogen. So here what it is? Electron donating group. So the electron donating group, who is having electron donating group? Yes, alkyl group is having electron donating group. So naturally electron density will be increasing. So naturally what it is? It is ready to donate the electron. Basic character will be increasing. So we can say this is secondary amines are stronger than primary amine. Why primary amine is less? Because only one alkyl group, whereas here two alkyl group, two supportive group is there to donate, whereas here only one. Yes, fine. Okay, now next question. Why aliphatic tertiary amines are weaker base than primary and secondary? In aqueous state, note the point. Suppose here, according to this point, number of alkyl groups is increasing. So naturally, what it is? Stronger base is this only. So the same idea when we bring it here. So here nitrogen, here alkyl group. This is tertiary, right? Tertiary amine. So naturally, this is lone pair of electron. So this is number of alkyl group which is increasing. So that means naturally this will be more stronger, isn't it? Yes, it will be stronger in gaseous state. Gaseous state. Okay, now what the question they are asking? In aqueous phase, aliphatic tertiary amines are weaker base than primary and secondary. Now we are coming to that point of weaker base in aqueous state. So the same way nitrogen, which is connected with what it is? Alkyl group, number of alkyl group 3. So here lone pair of electron. So lone pair of electrons, it has to donate with the proton. So when it is donating with, it cannot donate with the proton. Why it does not? Why it cannot donate to the proton? Because three bulkier group, three soldiers are around that central atom. So that means it cannot donate. So three soldiers are pulling. So naturally it cannot donate that electron to that proton. When it is donating the electron only, it is having the character of base. But it cannot donate the electron. So how come it will be possible for basic character? Yes. So that means it does not donate the electron. So because of that bulkier group which is attached to that nitrogen atom. So this is called steric hindrance. Steric hindrance. Okay, so this is called bulkier group which is attached to the central atom. We can say it is a steric hindrance. So it cannot donate this lone pair of electron. It cannot donate to that proton. So it does not have the character of basic in nature. Now we'll see the order which is stronger base and which is weaker base among primary, secondary, tertiary. So secondary amines are stronger than primary and tertiary and ammonia. Hope you're clear with this. The next question. Aniline is weaker base than ammonia. Let us go and analyze with that aromatic amines. Okay, now aniline, this is what it is. Benzene ring connected with amino group NH2. Whereas this is ammonia. Lone pair of electrons are available for both. This is lone pair of electrons. Now, as I mentioned, that lone pair of electrons of nitrogen which is attached to that alkyl group is electron donating group. It is supporting for that electron donation. So, naturally, it turns into basic in nature. Whereas here, that lone pair of electrons which is involved for the resonance. What is it? Which is where it is connected. That amino group is connected with benzene. Benzene is what it is? Electron withdrawing group. So when electron withdrawing group means naturally it take the lone pair of electrons to withdraw themselves. So naturally here benzene ring has taken the lone pair of electron to withdraw that electron for that resonance structure. Okay, so the lone pair of electron which is involved for that resonance, so it does not allow to take that to donate the electrons to that proton, so it couldn't get that proper basic character. Okay, now let us go and identify that resonance structure of aniline. Okay, now this is benzene ring and connected with the amino group and lone pair of electrons are there. Now double-headed arrow. So what happened? The lone pair of electron which is donating here. That means the resonance takes place. So the donating that pair here. So what happened? This bond, double bond goes here. So you will get that positive charge and double bond changes takes place. Here double bond takes place. See, here single bond, here double bond and positive charge, here negative charge, and here the bond turns no, so negative charge here. So here you will get the second portion. Okay, now third point, what will happen? So here the same way. Now here double bond, here positive charge, no, here NH2, here positive charge. So this one turns over here. So when it this one you will get it, so you will get the minus charge. So what happened? You will get the double bond and here also double bond, here you will get that minus charge. So minus charge returns over here. It is like a resonance going around. Okay, now what happened? So here you will get that double bond in this place. Okay, so here you will get the double bond, here you will get the double bond, and here you will get the double bond, and NH2 here plus charge, and here this chance it goes here. So you will get the minus charge over here. So your minus charge it turns over here. So what happened here? So here you will get that bond replacement here. So this bond, because it is alternative now, so when it comes this bond, this will go to that next position. So here single bond and nitrogen, and here you will get the double bond NH2. So this is the resonance point of aniline. Hope you're clear idea about the resonance point of aniline and why aniline is weaker base, because that lone pair of electrons is involving for the resonance. So it is not allowing that lone pair of electrons to donate, because which is attached with that benzene whom it has attached, that is the matter. When lone pair of electrons, that amino group which is attached to alkyl, so alkyl group is electron donating group, so it is supporting for the donation, whereas here benzene it is electron withdrawing group, so it will taken for the resonance. Hope your clear idea. Okay, let us go and identify some more questions. Now the next question, paratolidine and aniline, which is more basic? Paratolidine, the first one, paratolidine means methyl group which is attached to the para position along with amino group CH3 and NH2. So this is paratolidine. Toluene, so connected with amino group, this is paratolidine. Okay, and here aniline. Aniline, of course, you know very well aniline. So this is aniline. Okay, now due to that resonance, just now we mentioned, due to that resonance, it is amino group which is attached at electron withdrawing group. So naturally, basic strength will be lesser. When we compare to this toluene, toluene is having more basic strength. Why? Because which is connected to the methyl group. So methyl group is what it is? Electron donating group. So naturally, this will be more stronger. Paratoluene is more stronger than aniline. Okay, now next one, nitroaniline. The second one, what it is? Nitroaniline. Here, this is aniline, NH2, and here nitroaniline, nitro group, and here ordinary aniline. Okay, now here generally nitro group which is attached to that alkyl group. So electron withdrawing group, so naturally what it is, basic strength will be increasing, but whereas here nitro group which is attached to that phenyl, so the basic strength will not be increasing. So that is the reason now here in this which is more basic means in this is more basic. Aniline is more basic than nitroaniline. Why? Because nitro group, it is an electron withdrawing group that is attached to that phenyl group. So here that basic strength will be decreasing. So naturally, which is more basic means in this point aniline is more basic comparatively nitroaniline. Okay, hope you're clear with this. Now we are going to that order of that basic strength. Let us go and identify. See here the order of alkylamine we have gone through, that is secondary and primary and tertiary and ammonia we have gone through. Now this aromatic amines, let us go for it here. Dimethyl phenyl amine, that is more stronger. You see dimethyl which is attached, lone pair of electron which is attached that electron donating group. So naturally that will be more stronger base comparatively other. So why it is very strong base? Because of what it is. It is attached with the electron donating group. Yes, very good. Okay, now dimethyl phenylamine, it's stronger than methyl phenylamine and aniline. Aniline, of course, this is aniline is the third position. Okay, aniline and diphenyl aniline. So that is amine. Okay, diphenyl amine. So that is like a secondary. And the third one, it is a tertiary phenyl amine. So according to this, suppose if they are not giving in this way, if they are giving these three things, primary, secondary, tertiary, aromatic amines in that order. Okay, why these they have mentioned? Because methyl group which is attached, so methyl group is supporting for that to donate that electron pairs. So naturally basic strength will be increasing. Okay, now what is the proof to identify this and all means? Kb equilibrium if you are going means 11.7 into 10 to the power of minus 10 for dimethyl phenylamine and 7.9 into 10 to the power of minus 10 for methyl phenylamine, and aniline of course 4.2 into 10 to the power of minus 10, and diphenyl amine it is 6.6 into 10 to the power of minus 14. Look at this, minus 10 and this is minus 14, and the last one very low we could not identify. Hope you're clear with this. Give reason type questions. This will be helpful for assertion reason questions. Hope you understand. Thanks for watching.